All right, finally, we've got sp hybridization. So here our compounds are only going to be attached to two other things. So both of these carbons are sp hybridized because we are only attached to two other things. And in sp hybridization, you're going to have, these are going to be your sigma bonds. Your sigma bonds are always the first bond between any two atoms, and then anything beyond that are pi bonds. So for example, this triple bond right in the center has one sigma bond and two pi bonds. And so the idea is that we have this 2s orbital and then this 2p orbital, and only the s and the p will mix. And then we'll have two leftover p orbitals. They mix to form two sp orbitals, and then we'll have two leftover p orbitals. The sp orbitals, again, look pretty similar to the sp2 and the sp3 orbitals. It's just the orientation that's really different. And then, of course, we have leftover p orbitals. So let's go ahead and draw this molecule right here and think about what it looks like. So we have these two carbons here. They're both sp hybridized, so they both have two sp orbitals. One that goes like that, one that goes like that, and then they have direct overlap with one another. So we form a sigma bond, and then they're sigma bonded to a hydrogen on either end. And then they both have one empty p orbital facing in this direction. And there's an indirect overlap there. Should have made that one face the other way. Indirect overlap there. And then they have yet another empty p orbital back here like so, forming its second pi bond. Here's just a better image of that, right? On the left, you see the Lewis structure. On the right, you see the valence bond model. Note that here in this carbon-carbon triple bond, we have one sigma bond and two pi bonds. We can get further hybridizations of sp3d and sp3d2. I don't think they're that important, so we won't really cover them too much, or really at all.